The James Webb Space Telescope has uncovered something truly remarkable: beams of light that appear to radiate from an urban center, shining from a location light years away. This discovery has sparked renewed interest in the potential existence of extraterrestrial life. The telescope directed its focus toward Proxima Centauri b, the nearest exoplanet to our solar system, and noticed strange, brilliant flashes of light. Could these signals be from an extraterrestrial civilization? Stay tuned for more developments. The idea of life beyond Earth has captivated scientists and everyday people for a long time. There has been a lot of excitement over any evidence that life exists in space. But a pivotal moment came when the James Webb Space Telescope presented clear evidence suggesting the existence of life somewhere in the cosmos. While scanning the depths of space, this powerful telescope discovered something extraordinary. It detected lights that looked like those from extraterrestrial cities on a faraway exoplanet, raising the possibility that an extraterrestrial metropolis existed there. The scientific community is very excited and curious about this idea because it could be the breakthrough they've been waiting for. It hints at the presence of intelligent beings operating civilizations in ways we are only beginning to explore. NASA engineers are astonished by these city-like lights from a remarkable distance of 4 light-years away. They wonder how long they may have been visible in space while we waited for our technology to advance to the point where we could detect them. David Kipping, an astronomer at Columbia University, has described the planet where these lights were discovered as particularly intricate. Due to its unique relationship with its host star, Proxima Centauri, this exoplanet behaves differently than most rocky planets, which absorb sunlight and emit energy as infrared radiation. The significance of the James Webb Space Telescope is made clear by this finding. In order to comprehend the planet's atmospheric conditions, its capacity to capture infrared wavelengths was crucial in identifying Proxima Centauri b's unusual behavior. With the intention of determining whether or not this planet is habitable, researchers plan to continue using the telescope to examine the atmosphere in greater depth. The James Webb Space Telescope is particularly sensitive to infrared light, enabling it to observe what happens on Proxima Centauri b even during the night. Many telescopes struggle to detect faint light in the vast darkness of space, but the Webb telescope excels at picking up even the faintest glimmers. Because of this, it is an excellent tool for determining whether or not the alleged city lights on the dark side of Proxima Centauri b are real. The telescope can detect artificial light in space, provided it falls within a very specific frequency range, much narrower than the light emitted by regular stars. Proxima Centauri b has a dynamic interaction with its star, which heavily influences its environment. Like many planets that orbit stars, it captures intense energy from Proxima Centauri. As the planet revolves around the star, it goes through cycles of day and night. Similar to Earth, the planet experiences daytime scorching heat and nighttime cooler temperatures. Proxima Centauri b has a wide temperature range primarily due to its composition. For example, if the planet has an atmosphere, the temperature difference between day and night would be extreme, hot on one side and frigid on the other. Astronomers are particularly interested in this striking thermal fluctuation because it sheds light on Proxima Centauri b's atmospheric composition. With its ability to image in the infrared spectrum, the James Webb Space Telescope can effectively examine the planet's thermal emissions, providing insights into its atmospheric properties. Interestingly, the James Webb Space Telescope's orbit around Earth coincides with Proxima Centauri b's, making it possible for researchers to observe the star's daylight cycles in detail every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step will be to analyze its chemical composition to determine if it could support life. The presence of elements like oxygen, methane, and water vapor would indicate the possibility of life on the planet. This would necessitate the intricate study of light passing through the planet's atmosphere. The James Webb Space Telescope is designed primarily for other purposes, but it excels at characterizing planetary atmospheres. The concentrations of methane, carbon dioxide, and water vapor are its specialties. However, it lacks the ability to detect free oxygen, an essential sign of life. Nonetheless, the telescope can search for other key indicators, like ozone, which signals a healthy atmosphere. The search for distant worlds continues as scientists examine the James Webb Space Telescope's data. The search is getting us closer and closer to finding out if we are the only ones in the universe. It is essential to keep in mind that the James Webb Space Telescope is limited in its ability to observe the exoplanets closest to Earth. For more detailed studies of planetary atmospheres, astronomers will rely on ground-based observatories like the Extremely Large Telescope, ELT, which is set to begin operations in 2027. The ELT is designed to offer a deeper look at the atmospheric structures of far-off exoplanets, providing clearer and more detailed data on their potential to support life. Scientists are eagerly awaiting the launch of future space telescopes like the ELT. In the meantime, the James Webb Space Telescope remains an invaluable tool for exploring distant exoplanets. Despite its limitations, the Webb telescope continues to offer critical information that may change our understanding of what exists beyond our solar system. Future space telescopes are the subject of ambitious plans from researchers. They aim to develop technologies that reduce starlight interference, allowing for better observation of the planets around them. Similar to using your hand to block the sun in order to see more clearly, these upcoming telescopes will be able to focus on the faint light reflected by exoplanets, making it easier to analyze their atmospheres and assess whether they might be capable of supporting life. However, this task is far from simple. Stars are incredibly bright, often vastly outshining their surrounding planets. The faint light that planets reflect, which is necessary for studying their characteristics, is difficult to detect due to this brightness. Scientists are developing a number of novel solutions to this problem. The use of coronagraphs is one such strategy. These devices are placed inside telescopes to block out starlight while letting the light from the planet pass through. By carefully shaping the light waves, coronagraphs can significantly reduce the brightness from the star, making it easier to detect the dim light from exoplanets. Another promising approach is the Starshade, a massive, flower-shaped spacecraft that will fly in formation with a telescope positioned tens of thousands of kilometers away. The Starshade blocks starlight before it even enters the telescope, allowing only the light from exoplanets to reach the instruments. Planets with liquid water and possibly life in the habitable zone of their stars could benefit especially from this approach to observing them. However, these advanced technologies require extraordinary precision. For instance, the alignment of a starshade must be perfect to fractions of a millimeter over vast distances. Moreover, these innovations must overcome the limitations posed by space missions, including the need for energy efficiency, miniaturization, and the ability to withstand space's harsh conditions presents significant challenges. Despite these obstacles, the potential rewards are enormous. Successfully observing and analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical indicators of life such as oxygen, methane, or water vapor in specific ratios. These molecules might point to biological processes, suggesting that life exists beyond Earth. Researchers are also exploring ways to directly image distant worlds in greater detail. Advanced adaptive optics, which adjust for distortions caused by Earth's atmosphere or the telescope's movements, may be included in future telescopes, resulting in sharper images. Combined with starlight-blocking technologies, these improvements could allow scientists not only to detect exoplanets, but also to map their surfaces and study their climates. Our quest to answer one of humanity's most fundamental questions, are we alone in the universe, has made a significant leap forward with the development of next-generation space telescopes. We are getting closer to finding out if life exists beyond Earth by improving our ability to observe these faraway planets. This could change how we see our place in the universe. Space exploration and the search for life beyond Earth are moving at a rate never before seen, as scientists and astronomers dive deeper into the mysteries of distant exoplanets. The James Webb Space Telescope is opening a new era of cosmic discovery. The data it gathers is helping astronomers make groundbreaking revelations about the structure, composition, and potential habitability of far-off worlds. With each new piece of information, we edge closer to the ultimate question. Is there life beyond our planet? The discovery of Proxima Centauri b is just the beginning of what could be a significant turning point in our understanding of extraterrestrial life. Proxima Centauri b, being the closest exoplanet to our solar system, has been a focus of intense research for years. However, up until this point, the aspiration of many scientists was to discover tangible evidence of life, such as artificial light or signs of civilization. The Webb telescope's detection of such light only raises the possibility that we will one day communicate with other intelligent life forms in the universe. The public's imagination and scientific curiosity are stoked by this kind of discovery, which encourages future generations to consider possibilities beyond Earth. In addition to looking for artificial lights, the James Webb Space Telescope is also focusing on planetary atmospheres, their chemical compositions, and how these could support life as it continues its observations. The search for biosignatures, like methane or carbon dioxide in the right concentrations, is vital for understanding whether these planets have the right conditions for life. The Webb telescope has the ability to analyze these atmospheric components in a way no other telescope has been able to, shedding light on the potential of distant worlds to support life similar to Earth's. One of the most fascinating aspects of Proxima Centauri b is its location within the habitable zone of its star, where conditions might be right for liquid water to exist on its surface. The region around a star, known as the habitable zone, contains temperatures that are just right, not too hot or too cold, for the formation of liquid water. A planet's ability to support life is thought to depend heavily on this. Water is essential for life as we know it, making the discovery of an exoplanet within a star's habitable zone a key target for future missions. Future space telescopes will also focus on the intricate relationship between exoplanets and their stars, in addition to finding planets that support life. Some planets, like Proxima Centauri b, are tidally locked, meaning one side always faces the star while the other remains in darkness. This could result in extreme temperature differences between the planet's two sides, which would impact the planet's climate and its potential to support life. Understanding these conditions is critical for astronomers as they assess the likelihood of habitable environments on exoplanets. Another significant step forward in space exploration is the development of technologies that can block stars' bright light. Without the ability to block out starlight, it would be virtually impossible to observe the faint glimmers of light from distant planets. The coronagraph and starshade technologies mentioned earlier are prime examples of how scientists are overcoming these challenges by blocking out the overwhelming brightness of a star. These tools will enable telescopes to detect the faint light reflected by planets, which could reveal crucial details about their surfaces, climates, and potential for life. The idea of directly imaging exoplanets is another exciting development in this field. With the help of advanced adaptive optics and starlight blocking technologies, astronomers hope to capture high-resolution images of planets as they orbit their stars. These images would not only provide more detailed information about the planet's composition and atmosphere, but could also offer a closer look at the planet's surface features, such as oceans, continents, or weather patterns. This type of imaging would represent a giant leap in our ability to study exoplanets and make informed conclusions about their potential to support life. As we continue to explore the universe and search for answers about the existence of life beyond Earth, the role of the James Webb Space Telescope in future missions will be indispensable. The telescope's ability to detect faint signals from distant planets, analyze their atmospheres, and examine their potential for habitability is transforming our understanding of the cosmos. With advancements in technology and an ever-growing body of research, we are on the brink of making discoveries that could reshape our knowledge of life in the universe.